Welcome to Math Tutorials. In this video, we are solving every question of exercise 2.1 of Chapter 2, Inverse Trigonometric Functions, from the NCERT Mathematics textbook for Class 12, Part 1. Exercise 2.1 has 14 questions, 10 principal values to find, 2 expressions to evaluate, and 2 questions about ranges. The key to all of them is knowing each inverse function's principal branch. Here are the questions. Let's start with the first. Question 1. The principal value of sine inverse of minus 1/2. Remember, sine inverse always answers from the branch minus pi by 2 to pi by 2. Let y be sine inverse of minus 1/2. Then sine y is minus 1/2, with y in the principal branch. Sine of pi by 6 is 1/2, so sine of minus pi by 6 is minus 1/2, and minus pi by 6 lies in the branch. That is the principal value. Question 2. Cosine inverse of root 3 over 2. Cosine inverse answers from 0 to pi. Let y be cosine inverse of root 3 over 2. So cosine y equals root 3 over 2, with y between 0 and pi. Cosine of pi by 6 is root 3 over 2, and pi by 6 sits inside the branch. Done. Question 3. Cosec inverse of 2. The branch here is minus pi by 2 to pi by 2, leaving out 0. Cosec y equals 2 means sine y equals 1/2. Sine of pi by 6 is 1/2, and pi by 6 is in the branch. So the principal value is pi by 6. Question 4. Tan inverse of minus root 3, with the open branch from minus pi by 2 to pi by 2. Tan of pi by 3 is root 3. Tan inverse of a negative number is the negative of the positive answer, since tan is an odd function. Minus pi by 3 lies inside the branch, so that is our principal value. Question 5. Cosine inverse of minus 1/2, and here is where cosine behaves differently from sine. Cosine inverse of a negative number is pi minus the positive answer. The branch 0 to pi has no negative angles in it. Cosine inverse of 1/2 is pi by 3, so our answer is pi minus pi by 3, which is 2 pi by 3. Question 6. Tan inverse of minus 1. Tan of pi by 4 is 1, so by oddness, tan of minus pi by 4 is minus 1, and minus pi by 4 is inside the branch. Question 7. Sec inverse of 2 over root 3, branch 0 to pi, excluding pi by 2. Sec y equals 2 over root 3 means cosine y equals root 3 over 2. That happens at pi by 6, which lies in the branch. Question 8. Cot inverse of root 3, the branch for cot inverse is 0 to pi, open at both ends. Cot of pi by 6 is root 3, cot is cosine over sine, root 3 over 2 divided by 1/2, and pi by 6 is in the branch. Question 9. Cosine inverse of minus 1 over root 2, negative input again, so we use the pi minus rule. Cosine inverse of 1 over root 2 is pi by 4. So for the negative input, the principal value is pi minus pi by 4, 3 pi by 4. Question 10, the last principal value. Cosec inverse of minus root 2. Cosec y equals minus root 2 means sine y equals minus 1 over root 2. Sine of minus pi by 4 is minus 1 over root 2 inside the branch. So the answer is minus pi by 4. Question 11. A sum of 3 inverse values. We know each piece already from the earlier questions. Tan inverse of 1 is pi by 4. Cosine inverse of -1/2 from question 5 is 2 pi by 3, and sine inverse of -1/2 from question 1 is minus pi by 6. Put everything over 12. 3/12 plus 8/12 minus 2/12 of pi gives 9/12. That is 3 pi by 4. Question 12. Cosine inverse of 1/2 plus twice sine inverse of 1/2. Cosine inverse of 1/2 is pi by 3, and sine inverse of 1/2 is pi by 6. Twice pi by 6 is pi by 3, and pi by 3 plus pi by 3 is 2 pi by 3. Question 13. If sine inverse of x is y, what values can y take? This is exactly the principal branch question. By definition, sine inverse always returns an angle between minus pi by 2 and pi by 2, endpoints included. And the final question. Tan inverse of root 3 minus sec inverse of minus 2. Tan inverse of root 3 is pi by 3. For sec inverse of minus 2, sec y equals minus 2 means cosine y equals minus 1/2, and in the branch that is 2 pi by 3. Subtracting, pi by 3 minus 2, pi by 3 is minus pi by 3. That completes exercise 2.1. That completes all 14 questions of exercise 2.1. In the next video, we will take up exercise 2.2 on properties of inverse trigonometric functions. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.